Good morning all together. I welcome you to the second edition of Let's Talk Science, the IMO Hannover early morning Wednesday session to address interesting research activities at different universities in Germany, but also throughout Europe. Today, I'm pleased to announce Mr. Daniel Ranke from the Research Institute of Stuttgart, IPA, the Manufacturing, Engineering and Automation Institute. Daniel Ranke will give us his perspective on matrix production as a production concept to integrate various technology to increase efficiency. One organizational remark: if you have any questions, please put them into the questions box that you see on your screen. We will pick them up later on and discuss this with Mr. Ranke. So, Mr. Ranke, the floor is yours.
Thank you very much, Mr. Schäfer. Welcome by my side. I'm Daniel Ranke, as Mr. Schäfer mentioned. I'm from Fraunhofer IPA in Stuttgart, and I like to talk about matrix production systems as a new possibility for the integration of technologies. It's much more like a teaser today, more just giving some insights in our perspective. And I'd just like to start with a look in the past, in the present, and in the future. Each century has its main production system. Starting quite in the past, it was mainly just a single workstation production. Every people had its own production system in its home, producing its main product. And just after the Industrial Revolution, and by other guys, for example, like Henry Ford, there was just the introduction of industrial systems as we know them today. Henry Ford introduced the line production, being much more efficient in the production of his products, being much more cost efficient, and he had in this way he had a much more benefit in selling his products, being just more competitive to his competitors. But in the last centuries, the line production was and is not that mostly beneficial as it was in the past. There are much more product variants a customer can choose. There's much more possibility to make a personalization of your product. So today, if you think about the last century and about the next centuries, there's a high uncertainty about the volumes you make in a product and its variants, and it's not even sure if you just keep the technology you choose for your start of production, or if there are changes in volume and technology and process configuration of a product's life cycle. Further, there's the high number of variants. Each variant may have a different cycle time, so it's not even possible anymore to be efficient in a line production, because each station may wait for the other station due to the difference in cycle times. Furthermore, there might be the requirements to make an upscaling and a downscaling of a product life cycle. If you just think about the car manufacturing, there is a decrease in the engine, a diesel engine, for example, and there is an unexpected increase in electrical vehicles. So today, your production system has to adjust to these challenges over a product life cycle, and maybe it's not anymore that you ramp up a production system to your start of a product, but it's much more like you ramp up a production system in your factory and you try to implement and include even further products over a production life cycle. So if you think about taking these challenges into your production system, we're talking about, in our perspective and at our Institute of Matrix Production Systems. Matrix production systems are mostly flexibly linked process modules. What are process modules? I will talk to it in the next slides. But the concept of matrix production system is trying to adapt to new conditions in your from your outside and trying to to mirror them and to match them to your factory system. A matrix production system tries to adapt differences in quantities, variants, technologies, and processes over a production system's life cycle. It tries to be the answer, to be more flexible in your system, to be even productive with a high number of variants, and trying to upscaling and downscaling in a really incremental time step. Talking about matrix production system, in our perspective, we're talking that a matrix production system consists of flexibly linked process modules. A process module can be quite different in its configuration. For example, a process module can just be like at the top left side, a single station, a single workstation, where there can be operated manual processes which have differences in cycle times. So if you think about differences in cycle times in the context of line production, it's not easy to be efficient implementing all the different cycle times in your production line, because if there's a difference in cycle times, as you know, the left worker has to wait on the right worker, and waiting time is wasting time. It's not really lean. So there's the challenge to be more flexible in this context, and you can get it by just making it a little bit more independent to the other stations. If there are still tasks and processes which are mainly repetitive and there's no really differences in the cycle time, it's still interesting to make a process module like you see in the middle top, which is still like a line production, but it's not that you put every process in a line production, just the processes which are near together and which have no difference in cycle time. So there's a subsystem, you can say a subsystem as a line production just in your matrix production. And there might be even, of course, automatic stations for repetitive tasks and processes. And there again, the comparison to a line production. In a line production, you just have a fixed process chain. And there might be a process you like to automate at the beginning of your process chain and at the end of your process chain. And the task process at the beginning and the end is quite similar. But due to the process chain, and maybe there are important steps you have to do between these two processes, you have to decouple both processes and both stations. And it might be not efficient and not economically beneficial to make both processes, to automate both processes. So you still make it, you still process them by a human worker. But rethinking the system, thinking of flexibly linked stations, and thinking about you might just go to the station 2 times, to the same station 2 times. You can just put the volume of the first process and the volume of the last process together, and might be economically beneficial in this case. So a matrix production system allows you to go to the same station more than one time. It's important to think in matrix production systems mostly of decoupling of the stations or the process modules, being still open for some subparts of line productions, and thinking about standardizations of your process to try to combine multiple processes in one process module to get a high volume, and to rethink the automation concept. This looks maybe a little bit more like a chaotic system. It looks like conventional workshop systems, but it takes some part of it, but it's a little bit more complex, thinking about the control of the systems. Each station is not like in a chaotic layout. We try to locate it in a basic flow that, for example, you go from the left to the right side. And the control of the system is not like using, again, fixed process change, but everything is a decision making at an ad hoc basis, really on a short time. So there's not one main station to do one task. If you think about being more flexible, in our perspective, we try to make for critical processes a redundant station to maybe to make a second station, a third station for critical processes. So if there might be planned or unplanned disruption in your production system, as you can see, as you can see on the right bottom picture, like here or in this case, it's not like if one station just has a disruption, the whole system goes down. It's more like if one station has a disruption, only the system goes a little bit down, for example, like 10%. As mentioned, there are not fixed process change for your orders anymore in a production system. It's more, it is an order specific decision making in your production system, and it's not that you make the decision making far before the production start of your order. It's just during the production that the order is deciding which station or process module will be the next one. This depends on which operations which processes and operations are required by the order, but it's even in a second perspective, depending on where might be the lowest waiting queue for your product and overall stations, which might be off by the needed process and tasks. If you think about it, not like a fixed production system, but like an infrastructure which is offering different processes and technologies to your orders. The same case, I talked about the disruption of different modules and stations. You can just add a second or a third or a further new technology to your production system if there are some changes in your production system or your offered products to the customer. So if there might be a new product variant where you require, for example, additive manufacturing processes which are not displayed yet in your production system, you don't have to change the whole system. You just have to add a process module or your station which is offering the process for additive manufacturing. On the contrary, if you can see that there are technologies which are not required anymore to your product, you can just put them out of your production system. And you don't have to stop the whole system to do incremental changes. You just have to stop one or two stations which are affected by the changes, but the whole system around these one or two stations is still operating beneficial. So putting this, for example, to an example, talking about the car manufacturing. Today we see that there's a rise in electrical vehicles, but you don't know how far this will go on, or actually how the politic system will decide, for example, if there might be no diesel vehicles allowed anymore after 2035, or if there might be more hybrid customer demand. For example, some customers go still to the diesel vehicles, but how many people will go to the electrical vehicle? This is not really, not easy to say for the future. So you have to design your production system much more flexible, and there might be points over a production life cycle that you have to do some changes. And in this case, we talk about flexible corridors and the change between flexibility corridors over the time. So not thinking about just one product life cycle and making a production system to only one product and its variants, it might be interesting to think about what products do you want to process into manufacturing in your company, in your factory, and isn't it more interesting to just think about an infrastructure a product might use, and you change your infrastructure according to new products and decreasing products, but it's more like a life cycle of a production system which is just continually adapting through changes in your product demand of the customer. So going to this picture, it's not like you ramping up a production system for your new electrical vehicles and you're ramping down the production system of your diesel vehicles. It's interesting to think about, are there not a lot of processes common between both cars? Of course, there are differences in the between the electrical motor and the diesel engine. These are completely different parts, and there might be completely different stations to build in these parts, but still a car might be a car. So the interior processes and the exterior processes to put, for example, to put in a seat or a wheel into your car might be still the same. Of course, in detail, the parts, the seats may be different, but the processes to put in these parts might be still the same, and the knowledge the worker needs to put in is still the same like the past years. So thinking about the system that you today have much more stations putting in the diesel engine. You have some stations to build in the interior and the exterior, and there are a few stations to put in the electrical motor. It might be interesting to think of the production system as an infrastructure which is just changing over time, not totally ramping down and not totally ramping up. That if you put both car types together in one system, you can just think that you keep the stations and the process module of the interior and the exterior process, keep them quite the same over time, but you just decrease the diesel engine stations and you increase the electrical motor stations. And due to the decreasing complexity of electrical motors, there are in total in the future maybe less stations to put in the engine or the motor. But as you can see, you have done some changes in your system, but there are still some aspects in your system quite the same, like this example, the interior and the exterior stations and processes. So yeah, short summary of matrix production system. We're mainly talking about flexibly linked process modules. A process model can be still a subsystem as displayed as a line system if there are low differences or small differences only in the cycle time, if they're easy to put in one fixed chain. But if you're talking about variants and processes which have really high differences in the cycle time, if there are differences in the demand, it's interesting to think of decoupling these stations and being a little bit more flexible. Of course, there's an increasing of work in process material, but of course, it's not like you only get the benefits and there are no disadvantages. There might be an increase in the work in process, but if you can just increase your flexibility and be much more productive, it's thinking about maybe I take a little bit more material waste and in your material demand and your work in process material, but you get much less space in thinking about the productivity of your worker and your resources. So the advantages of a matrix production system are that you can just implement a high number of variants in your production system. It's much more easier to make an up and down scaling depending on the requirement and the customer demand. And thinking about the technologies, thinking about the automation of processes, you have a much more planned utilization. You are much more effectively in using your resources and making it much more easily to automate processes by just combining the demand of different processes at one single automation station. So this is not only a theoretical model. We have projects trying to implement matrix production systems in different factories. And one project we had together with Siemens in Karlsruhe. They built industrial personal computers, industrial PCs, and they had the requirements that they were still, of course, producing a lot of products, but they had the feeling that they are not so productive anymore. So we did a project together with them, looking into their manufacturing and assembly processes, and we looked where do we have to decouple some stations and processes, and where is it still beneficial to use the lean line design, the line production system. So we designed some parts they are still having the lean line, and we designed some parts where they had decoupling stations, high automation level, and linked all of these stations by an HDV system. So today they are even more productive and they are even more flexible. So in this case, they mostly have only advantages in the system. They have a little bit increasing work in progress, but yeah, in total they are really happy with their new solution. And overall, there are mostly advantages than disadvantages to this kind of production system. So when might be it interesting to think about matrix production system? And this might be the last slide. Thinking about matrix production system, it's interesting if you require a high productivity and a high flexibility due to the fact that you have a high number of variants, but in each variant you have a small batch size or a small number of units. But in the total perspective of all your variants and all your production products you like to produce in your production infrastructure, you still have a high volume. So if you just have a high volume but low variance, it's still beneficial to use the line manufacturing, line production system. And if you only have a high variance but low volumes, it's still interesting to think about shop floor manufacturing or single workstations. But if you have to combine both, really high variance, a really high total volume, but a low volume in each variant, it's interesting to think about matrix production system, thinking about decoupling stations, and redesigning your production system. There's still another name here, the fluid production system. It's still mostly, in our perspective, a research topic. It's, for example, in Arena 2036 here in Stuttgart. It's a research campus. So it's more like an outlook that there are even more flexible systems in the future, which can be much more adaptable in a short perspective, changing a production system each day. So this is more like a teaser for the future. But the matrix production system you can see here in the middle are quite interesting for many companies. We are doing a study just at the moment, and we had a lot of insights in different companies. And there are many companies trying to redesign their production system in a direction of a matrix production system. So I'm coming to an end. I thank you for your attention. And if you have any questions, you can just put them into the question panel or in the chat, and I'm trying to answer them. Thank you.
Thank you, Mr. Ranke, for this very interesting view on matrix production as a new, let's say, concept to, let's say, combine both worlds, volume and flexibility. From my side, yes, I have one or two questions. First of all, is there a borderline of volume where you say, here matrix production would not really work? Or on the other hand, is how much overlapping of processes is necessary that matrix production is really efficient? If let's say there's let's say new aspects in a new variety of a product is going in a totally different direction. As you mentioned, once all of a sudden you want to integrate additive manufacturing, but this is only very small portion.
Yeah, I try to answer these questions. It's not like I can give a fixed number and that's a limit where it's productive or beneficial. But talking about some past projects, for example, we have quite now a project where it's quite at the border where it's thinking, yeah, it might be going to a metric production system, and the total assembly time, total production time of a product is around about 10 to 15 minutes of these products, and the volume is about 50,000 units.
Okay.
So yeah, you still need some volume, but it's like, yeah, if you have a higher total manufacturing time, it's still that you can decrease, or the required volume is decreasing. And talking about the matching of processes, that's even more use case specific. That's hard to say at the moment without the use case.
And of course, once you set up such a system, you may have first view on an efficient structure, but with possible changes, the production management system needs to handle more complexity. Is there specific topics, specific tasks that are required here, different from past production management systems?
Yeah, the most challenging part introducing the metrics production is the control of the system. It can be much more complex. There are systems you can buy to control it, but we always say it's not like you're changing the hardware and everything is working. You have to look on the software side as well, and you have to change hardware and software combined. So we have to implement some rules to control your system, but it's not like you need to implement AI and only using AI, artificial intelligence, your system is working. You can still use conventional heuristics and conventional rules to control the system, but you have to mostly do some adjustments to your system, yes.
Okay, thank you, Mr. Ranke. I think this was also some interesting additions to what you have mentioned. So thank you for listening to this Let's Talk Science edition today. We will have the next edition in 1 month to go with a topic on the project EU Pro Giant, how SMEs become sovereign data holders. So be back with Let's Talk Science and have a nice day. Thank you and goodbye.
Thank you. Goodbye.